Okay, so welcome back. In this video, we'll continue with the fourth section of this chapter, which is about Laplace's formula, but today we will see the matrix adjoint concept. So, part 4, we have the definition. Okay, and we'll see the concept of matrix adjoint. So the matrix adjoint or it's also known as classical adjoint. Classical adjoint or adjugate. Okay. Okay. So the matrix adjoint to the square matrix T is the following. Is known as adjoint of T equals, so T1 1 T1 2 T1 sorry okay. T1n, so it's written a bit differently. If you can see here, normally this should be written horizontally in the rows, but now the rows are written as columns. Okay, so this is the tricky part about adjoint. It is like the transpose of the normal cofactors. Okay, so normally if you want to write cofactors, normally we should write T1 1 as in rows. Okay, T1 2, okay, T1 n. But this time, instead of writing the cofactors, I'm sure you remember T, the big T's, the cofactors are written in column. Okay, so T2 1, T2 2, T2n, T and 1, okay, T and 2, and T and n. So basically, to find the adjoint of a matrix, you just find the cofactors, and you remember to write them in column wise instead of row wise. Okay, we'll do some examples shortly. Where the row I, column j entry, okay, formed by the cofactors t, j, I, okay, is the t, j, I cofactor. Okay, and let's see a theorem here. So the theorem says the following: where t is a square matrix, then T multiplied by the adjoint of T is equal to the adjoint of T multiplied by T. So that means it is commutative. T multiplied the adjoint of T is equal to the adjoint of T multiplied by T, which is equal to the determinant of T multiplied by the identity matrix. Okay. First, if T has an inverse, that means if determinant of T is different from 0, then we have a nice formula here to find the inverse of T using the adjoint and determinant is equal to 1 over determinant of T multiplied by the adjoint of T. Okay, so let's do one example to illustrate the definition and the theorem. So here, 6, we have example. Okay, so the example says the following. Okay, consider the matrix. Okay, let me split it into 2. The matrix T, which is equal to 1, 2, 0, 2 minus 1 is 0, and 3, 1, 2. Consider the following matrix. So we are asked to find part A, the adjoint of T. Okay. Part A, find the adjoint of T, and part B, then find the inverse of T. Okay, so what we have to do here is to find the adjoints of T as firstly, so let's start solution. Okay, to find the adjoint of T, before we can find the adjoint of T, we need to find the cofactors of T. Okay, so if you remember, the cofactor T I j is equal to minus 1 to the power of I plus j multiplied by the determinant of the minor T tilde ij. So if you remember, the minor T tilde ij is the matrix we get by deleting the I row and the j column. Okay, we will do plenty of examples shortly. So basically, at the end, the adjoint of T is going to be the following: T1, 1, T1, 2, T1, 3, T2, 1, T2, 2, T2, 3, and T3, 1, T3, 2, T3, 3. So we need to find all these T. So T1, 1 is going to be equal to minus 1 to the power of 1 plus 1 multiplied by the adjoint T11. That means the matrix we get by deleting the first row and the first column. So if we delete the first row and the first column, we are left with minus 1, 1, 0, 2. Okay, so this is equal to 1 multiplied by determinant of this matrix is minus 2, sorry, minus 1 times minus 1 times 2 minus 1 times 0, which is equal to minus 2. So T11 equals to minus 2. Okay, let me get more space here to see if we can fit everything on this page to make our life easier. Okay, so but I'm not sure, but let's make the most of it. So T12 is equal to minus 1 to the power of 1 plus 2 multiplied by the minor, okay, matrix we will get by deleting the first row and the second column. So we are left with 2, 3, 0, 2. Okay, I will do it for the first few and then I will stop. So if we delete the first row and the second column, we are left with the matrix 2, 3, 0, 2. Okay, so we have here minus 1 multiplied by 2 by 2 minus 3 by 0, which is equal to minus 4. T12 equals minus 4. Now let's get T13 equals minus 1, 1 plus 3. The matrix, the minor, we will get by deleting the first row and the third column. So we will be left first row and third column, we will be left with 2, 3, minus 1, 1. Okay, so this is going to be minus 1 to the power of 4 is going to be 1. So we have 2 multiplied by 1 minus 3 multiplied by minus 1. So it's equal to, okay, 2 plus 3 equals to 4. 5, sorry. 5. T1, 3. 2 plus 3 is 5. Okay, so now let's get T21 equals minus 1 to the power of 2 plus 1, the minor of deleting the second row and the first column. Okay, we are left with the 2, 1, 0, 2. Okay, so we have a minus 1 multiplied by 2 times, okay, sorry, here we have a, yeah, it doesn't change the answer, but the minus is there. Okay, yeah, now everything is good. And a big bracket here, minus 2, 2 by 2 minus 1 by 0. Okay, so we have minus 1, so it's going to be minus 4. T1 is equal to -4. Now let's find T22, which is equal to -1 to the power of 2 plus 2 multiplied by the determinant of the following matrix. If we delete second row and second column, we are left with the -1, 3 and 0, 2. -1. Okay, second row, second column. We are left with it's not -1, huh? It's 1. Let's just be very careful here. Okay. Is 1, not -1. This is 1. Okay, so we have 1, 3, 0, 2. So here -1 to the power of 4 is going to be 1. So here you have 1 multiplied by 2 minus 3 multiplied by 0, which is equal to 2. So T2 is equal to 2. And now let's find T23 equals to -1 to the power of 2 plus 3 multiplied by our minor. Careful here. Okay. Okay, if we delete the second row and third column, we will be left with 1, 3, 2, 1. 1, 3, 2, 1. We have -1 multiplied by 1 minus 3 by 2. We all know how to get the determinant of a 2 by 2 matrix, okay? So let's say we have the matrix A, B, C, D, then the determinant, let's say this is equal to A, that means determinant of A, okay, determinant of A is equal to A D minus BC, so AD minus BC, which is equal to -1 multiplied by 1 minus 6. Okay, so it's going to be -5 equal to 5. T23 is equal to 5. Now let's find T31. T31, which is equal to -1 to the power of 3 plus 1 multiplied by our minor. Third row, we delete third row, and first column will be left with the 2 minus 1 0 0, and this is going to be equal to, this is 1 minus 1 to the power of 4 is going to be 1. We have 2 multiplied by 0 minus 1 multiplied by 0, which is 0. T31 is equal to 0. Now let's find T32, which is equal to -1 to the power of 3 plus 2 multiplied by the minor of deleting third row and second column, so we will be left with the matrix 1, 2, 0, 0, which is equal to, here is -1 multiplied by 1 times 0 minus 2 times 0, okay, which is 0. T3 2 is 0. And finally, let's find T3 3, which is equal to minus 1 to the power of 3 plus 3 multiplied by our minor. Okay, we delete the third row and the third column. We will be left with 1, 2, and 2 minus 1. Okay, so we have this is going to be positive 1. We have 1 multiplied by minus 1 minus the determinant. Okay, is equal to minus 2 multiplied by 2, which is minus 1 minus 4, which is minus 5. So T3 3 is equal to minus 5. So now we can write down the adjoint of T. Okay, so let me change color. We have seen that this is the adjoint of T. Okay, so now let's write it here. Adjoint of T is equal to, we have T1 1 here. T1 1 is equal to minus 2. T1 2 is minus 4. T1 3 is 5. T2 1 is minus 4. T2 2 is 2. T2 3 is 5. T3 1 is equal to 0. T3 2 is 0, and T3 3 is minus 5. So here is the adjoint of T. Okay, so we have minus 2, minus 4, 5, yes, minus 4. Okay, 2, 5, 0, 0, minus 5. Now, part, okay, so this was part A. Okay. This was part A. To find the adjoint of T. Now we are asked to find the inverse, and we have seen, let's go to next page, we have seen earlier in this video that the adjoint, that we can get the inverse. We have seen earlier that the inverse of T is equal to 1 over determinant of T multiplied by the adjoint of T. Okay, we have seen the adjoint already. We know the adjoint. Okay, now we need to get the determinant of T. So let's find the determinant of T. Okay, we have here, if you remember as well, we said that T times the adjoint of T, okay, is equal to determinant of T multiplied by the identity matrix. Okay, so what we are going to do is to multiply T. Okay, we are not going to find the determinant using Gauss's method, but using this equation. So we are going to multiply T by the adjoint of T. So here we have our T, which is 1, 2, 3, 2 minus 1, 1, 0, 0, 2, multiplied by the adjoint of T, and we have seen that the adjoint is minus 2, minus 4, 5, minus 4, 2, 5, 0, 0, minus 5. Okay, which is equal to, here we have minus so we have here minus 2 minus 8 is equal to minus 10. Okay, and here minus So minus 4 plus 4 is equal to 0. Here as well we have 0. In the second row we have minus 2. 2 multiplied by minus 2 is minus 4, plus 4 is 0. Okay, and here we have minus 8 minus 2 is equal to minus 10, and here 0, 0, 0 is 0. And here we have minus 6 minus 4 plus 10 is 0. We have here minus 12 plus 2 plus 10 is also equal to 0. And here we have 0, 0, minus 10. So minus 10. So it says if you multiply t by the adjoint of t, okay, this formula says we need to get here multiply by the identity. So we can write this matrix as minus 10 times the identity 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so that means the determinant of t is equal to minus 10. So now we can use that to find the formula of our inverse. Okay, let me say that t inverse is equal to 1 over determinant of t. Okay, so that let me get rid of this one, write it here. T inverse is equal to determinant of t, 1 over determinant of t multiplied by the adjoint of t. Okay. Okay, and we have seen this. Okay, this formula and this formula, these two formulas, we have seen them in the earlier in this video in the theorems. In one of the theorems, yeah, we have seen only one theorem. In the theorem of this video, we have seen those formulas. So we have the inverse of t is 1 over minus 10. Okay, so minus 1 over 10 multiplied by the adjoints, which is minus 2, minus 4, 5, minus 4, 2, 5, 0, 0, minus 5. Okay, so which is equal to 1 over 5. Here we have 2 over 5, 0, 2 over 5, and minus 1 over 5, 0. And here we have minus 1 over 2, minus 1 over 2, and here we have 1 over 2. So this is how we can find the inverse of a matrix if we know its adjoint. Okay, this is another way of finding the inverse of a matrix. If you remember in the previous chapter, we have found a way of finding the inverse of a matrix by doing, Gauss's method, by writing the matrix as augmented matrix, okay, and performing Gauss method to get the inverse of a matrix. So here is with this theorem we can get the inverse of a matrix, but as you can see, it's very expensive, it's very demanding to find the inverse of a matrix this way. So the best way is just to perform our Gauss method on the augmented matrix. Okay, so thank you, and this is going to be the end of this part, this fourth part of this fourth section of this chapter, and see you in the next part. Thank you.